Now let's start with the chemistry from this angle. This is the solution. So this question has to do with empirical and molecular formula. So the question here asks us to calculate what we call the molecular formula when the empirical formula is given to be NO2. So in order to solve for this molecular formula, what are you expected to do? So this is what we are going to do here. So the givens include this one here. So for the molecular formula, I'll be using MF for it. So that is equivalent to when you have your empirical formula in your brackets, then you indicate with an unknown equals to what we call the molar mass. If you are not given molar mass in the question, you can be given what we call the relative molecular mass, or you were given what we call the relative density. The relative density you have to multiply by 2 before you can solve the problem. So let us proceed. So here we go now. Our empirical formula is given to be NO2, close the bracket. We are going to have X equals to, this one is given to be our molar mass, which is 92.0. Now, from what you have in this place, remember or recall in chemistry, N equals to what? N equals to 14, O equals to what? 16.0, then 0.0 here. So from what you have there, this one, N is what? N is 14. That is 14 plus oxygen 16 times 2. Okay, X in this place equals to 92.0. So the next thing now is you do this one here, that is 14 plus this one will give you 32, then X equals to 92.0. Now the total value of everything that you have in this place, that will give you 46. That is 46 X equals to what? Equals to 92.0. So that is equivalent to, from what you have here now, you open the bracket, so you are going to have 46x equals to 92.0. Divide both sides by 46. Now, here we are going to have this one a, this one a. X becomes what? 2. If x becomes 2 in that place, now for this, the value of this one right from the start, we are going to have NO2, close the bracket, then multiply everything here by 2. That will give you N2 followed by, will give you O4. So this is our final answer there. This is what the question asks us to calculate. N2O2. That is our final answer, which is for the molecular formula.